Biology, Energy Processing. In this unit, our topics will be metabolism and ATP, cellular respiration, fermentation, and photosynthesis. So let's get started with metabolism and ATP. Metabolism is the totality of an organism's chemical reactions. Metabolism is a property of all life. A metabolic pathway begins with a specific molecule and ends with a product. Each step is catalyzed or sped up by a specific enzyme. Without enzymes, metabolic pathways would proceed very slowly. There are two types of metabolic pathways: catabolic pathways and anabolic pathways. Catabolic pathways. Catabolic pathways break down molecules from the environment. Living things use the energy derived from breaking the bonds in these molecules to build structures and drive cell processes. Exergonic reaction. Catabolic pathways are exergonic reactions. The change in Gibbs free energy is negative. Thus, they release energy and occur spontaneously. So if we take a look at this graph here, you can see this axis is looking at the amount of free energy, and this is looking at the progress of the reaction. So here you see the amount of free energy in the reactants, and here the products. And you can see that the amount of free energy released during this reaction is negative, or less than zero. Therefore, there is a negative change, and this process can occur spontaneously. Anabolic pathways. Anabolic pathways synthesize complex organic molecules and power cell processes using the energy derived from catabolic pathways. So some examples of anabolic pathways include building bones, building muscles, building starch, and powering active transport. Click here for a mnemonic device. Endergonic reaction. Anabolic pathways are endergonic reactions, and so here the change in Gibbs free energy is positive. Thus, they require an input of energy and do not occur spontaneously. So here we have that a similar graph to what we just saw. Here is the free energy, and this is the process of the reaction. So here you can see the amount of free energy in the reactants and in the products. And here you can see that the amount of free energy required, or that change, is more than zero. So it's positive. It requires an input of energy, and it does not occur spontaneously. Spontaneous processes. A process will occur spontaneously if the result is a reduction of the Gibbs free energy in the system. Gibbs takes into account the resulting change in the energy of a system and the change of its entropy or disorder. If the effect of the reaction is to reduce Gibbs free energy, the process will be spontaneous. If a change in Gibbs free energy is negative, it will occur spontaneously. If the change in Gibbs is zero or positive, it will not occur spontaneously. Free energy and metabolism. Biological systems often need an endergonic reaction to occur, but on its own, it won't proceed spontaneously. To be able to occur, the endergonic reaction is coupled to a reaction that is exergonic, so that together they are exergonic. Adding coupled reactions. Here you can see two reactions that have been coupled together. The first reaction here is a non-spontaneous reaction, or an endergonic or anabolic pathway. And you can see that because the change in Gibbs free energy here is positive. Because it requires an energy input, it couples itself with an exergonic reaction here that has a negative change in free energy. And the excess energy here is used to help power this reaction. So together, these reactions are spontaneous.